to compare, and why we talk about interest rate equivalence, and the idea of this is, if we have, suppose you have two offers from different credit card or different banks, and they quote to you different interest rates, but one says this one compounds monthly, the other compounds weekly, the other daily, and so on. How can you compare the 2 or 3 different offers? We express by convention, we put everything into annual compounding. So we use all the same measurement as what if this would be compounding annually, and then we pick which one is best. So we take everything into what we call the effective annual rate. We find what is called the effective annual rate, the EAR. We call it the EAR. Banks will quote to you. Let me see if I can paste it. No, apparently I can't. Yeah, it looks terrible. But banks will quote to you usually it's even worse. So banks will quote to you the interest rate called APR. No, that's the one. Have you seen your credit card statement? Okay, they usually will tell you the APR, and by law they have to quote that to you. However, as you can imagine, usually the quoted rate is in reality lower than the actual rate that you end up paying. So it's a tricky thing. So banks will quote to you the APR, or annual percentage rate, or nominal rate. This is the one, exactly. Our goal is always to find what is the EAR, or effective annual rate, or you're going to see sometimes in the book they call it EFF sometimes. So this is our goal. We want to find what's the effective. That's the question. How do we do that? There's a formula for that in the book, and also you can use a calculator, and there's a sequence of keystrokes you can click. The easiest way for me now is just to put what is the APR as a percentage here, and then we're going to find the EAR as a percentage here. So notice our APR is 18%. No, that's the quoted rate, 18%. So we just use this function called EFF. This is a function. Is effect actually. This is the name of the function. Equal effect, and we will enter here the nominal rate, which is 18%. That's a quoted rate, the APR, and then how many compounding periods per year. This is if they say 18% with monthly payment of interest, meaning we have 12 months in a year, so we put 12. If the rate would say daily compounding, how many compoundings per year we will have? 360 or 365, yes. Okay, fine. So in reality, what does it mean?
They gain 1.5% points on you.
Yes, the actual rate is a 1956, 1.56 percentage points higher than the quoted rate. They're following the law. They're not. The credit card companies are not misleading us. I mean, they might be, but they're following the law. They're complying with the law, which says it as APR. So, because if you look at the problem, says the interest is paid monthly. When will the only time be when APR or nominal is the same as effective? The only instance when this will be the same is when you compound things annually, yes. So you see, that's the only instance. Other than that, always the effective will be higher than the nominal. And if you don't, let's look at the intuition behind it. Suppose you have $100 today, and the quoted rate is 18% interest rate with monthly compounding. Okay, so let me put this in the so we have This is not a nice color, no? So let's try. So we have here, suppose this is the, let's do 12 months. So we have 1 year, we deposit $100, and this money grows at 18% with monthly per year with monthly compounding. So our we have 1, 2, 3, 4, 5, and all the way to 12 months in 1 year. This is 1 year, so we have 12 months. The rate is, the APR is 18% with monthly compounding. This is W with monthly compounding. Meaning every month, how much, what is my interest rate? Compounding. Okay. So what's my monthly APR, or monthly, actually my monthly percentage rate, MPR, because APR is annual. No? What's my monthly rate? Yeah, I would do, to get the monthly rate, I would do 18 divided by 12 months. 1.5 per month, no? Per month. Okay, so we have here, our interest rate is 1.5 per month. We have $100 today. How much will we have after 12 months? No, more than 120. Or no? Let's see it. Look, this is what we're going to do. We're going to try to find. Are you following me, or did I lose you? Okay. This is what we're trying to find. We have 12 months, no? We have 12 months. Our interest rate is 18, but divided by 12. So we have a 1.5% monthly interest rate. We have $100 deposited today, so we can do nearly 100. My question is, how much will we have after 12 months? Okay? So notice, this is monthly. This is also monthly. The rate and the number of periods and the payment, these three here, they all have to be expressed in the same time period. Okay, so if one is monthly, the other two need to be monthly. Okay, so let's find the future value. Future value is our interest rate, which is 1.5 per month. Number of periods, our payment, nothing. Our present value is 100. So, did you get that? Yeah, less than. The ballpark. Yeah. Okay. Yeah. Good. Okay. So you understand that we got the 119.56.
What threw me off was I got it right the first time.
Notice.
1.5. I put 1.5 and then it made it wrong.
But notice now. This is what this implies is that I have, after 1 month, how much will I have? I have 100 plus $1.5.
So it's the whole amount divided.
Yes, we will have 1.15. After 1 month, we will have 1.5% more, and so on. So we'll continue to have always 1.5, until the end. Our future value becomes 119.56. So what's the interest rate? 18% annual with monthly compounding. Let's do. Isn't that the same as what if I have the interest rate with, so same situation here, but I'm going to do with annual compounding, and notice that the rate that we just found, the 1956 here that we just found, yes, I'm going to use that one as our interest rate, and we're going to grow for 1 year 19.56% per year with annual compounding. My original $100 becomes 119.56.
So when you do it that way, you still have to go with the actual effective rate versus the APR.
Exactly. This is,
You have to find the effective rate first.
yes, what we are doing is called interest rate equivalence, C. We're trying to find what is a rate that will make the 18% annual with monthly compounding equal to 19.56 with annual compounding. And then you see that the future value under both cases is the same. The difference is this is annual, 1 year. This is annual as well, and this is annual. Well, oops. So you see they are the same. They are basically the same, but one is annual, the other is monthly. So banks will quote to you the lowest rate. So well, we could do the table if you want, but eventually we can grow the 101. Sometimes you know the effective. Let's say you're on the other side of the table, and you want to quote the rate, and you want to make your customers feel happy. I'm charging you a lower rate. So, so suppose you want to earn 15% effective annual rate. Okay. What rate do you have to quote to your customers if you want daily compounding? You want them to be happy, so you're going to quote to them a very low rate. You're going to see, look, I'm going to consult with my supervisor, and this is the lowest rate I can give you. So what's the rate? We find the nominal. It's called nominal. That's a function, nominal, and we use the effective as our input. So write it down, because you're going to, in the exam, I usually ask these two questions: find the effective rate, and then find the nominal rate from an effective. So it will be there. There will be a question on this. So suppose we have a daily rate. We want to do daily compounding, as credit card companies do. So we use 365 as our number of compounding periods. That's yeah, because 360 is lower, so 365 will be higher.
Well, it depends on what hat you have.
Yeah. Yeah, exactly. Let's say now we're bankers, or we are providing financing to our customers, and we want them to feel happy. Yeah. So we're gonna quote a lower rate.
So what does that say in TV online?
What this says is number of periods per year. The Y stands for year. Yeah. Yeah, it can be confusing, but so I have a slide on that, and when I say, let me see if I find it. There's a slide on the number of compounding periods per year. Let me show you real quick. It's towards the end about this one. So yeah, here it is. This is the formula approach. I used to have one. I think I can never find it, but I know it's somewhere. It doesn't say. Where am I? Well, but this is. Do you want to replicate this one in the book that I did on the? So, look, if it's effective, suppose. Let's go back to our example here. Suppose the effective one is 10%, and you want to have this with annual compounding is 10%, no? With semi-annual compounding, so twice a year, we just put 2 as the number of periods. So it's 976. Let's do with quarterly. So we have 4 quarters in a year. 967, so it's higher. It's 80 times lower. Monthly, 12 compounding periods per year. 957, lower, even lower, no? Daily, 953. So, so you think, oh, I'm getting 953%. Yes, with daily compounding. So your actual rate is 10. It's not 953.